Okay, so far we've been talking about how work power and the types of simple machines and how to calculate their work and their mechanical advantage. The last thing that I want to get into for this semester is something called mechanical efficiency. How well does the machine work is basically when using a machine to do work, two forces have been involved, and we talked about this several times. The first thing we have is the force that you put into the machine. That's the force in. It's what you apply to a machine. For example, when you're using a shovel, you have to apply a force to the shovel, and then the shovel will apply a force to whatever it is you are digging up. And then you have what is called the output force, and that's the force that the machines applies, and that would be, as I mentioned just previously, this would be what does the shovel apply to the dirt. Okay, so force in and force out, and when we calculate that, the work is always calculated by taking the force in and dividing by the force out. Okay. Now, we also mentioned that work can be calculated if we know the amount of the force and we know the distance that the force is being applied. That's called the input force and input distance. We can also do the same for our work output if we know how much force is coming out of the machine and we know how far the object is being moved. So, ideally, without friction, the work amount in is always equal to the work amount out. Again, that's in an ideal situation, but that is not the real world. In the real world, we have friction. So we don't always get out as much as we put in. And that is where we get into mechanical efficiency. So, efficiency is simply a comparison of the work out to work in put into a percentage, basically. So it's just a ratio or a comparison of those two. You have to realize, because friction takes away energy, the amount of work out is going to be less because of that energy that gets lost due to friction. No machine, absolutely no machine is 100% efficient. Okay? So that is something to remember. So let's work on calculating efficiency. So in this particular case, we have a machine that requires 40 joules of work to produce 30 joules of work. So how efficient is that machine? Okay. Now we can do this by looking and comparing forces. We can do this by comparing the amount of energy. All these are different things as long as we are comparing what goes in to what goes out. In this case, we're measuring work out and work in. Work, again, is measured in joules, force times distance. Okay, so we take the work out, in this case is 30 joules, and we're going to divide that by the work in, and then once we have that calculation, we simply multiply that answer by 100, and that gives us a percentage. So 30 divided by 40 gives us 0.75, it's 3/4, and we multiply that and we get 75%. This particular machine is 75% efficient. Okay, so again, we'll just do another example. You are going to perform 250,000 joules of work in cutting the lawn with a hand mower. If the mower in turn does 200,000 joules of work on the lawn by cutting the grass, what is the efficiency of this particular lawnmower? Again, because of all the grinding gears and different things that are going on, some of that energy that you put in is going to be lost. That's why it's only 200,000. So how efficient is this particular mower? Again, work out divided by work in, multiplied by 100. So we take the 200,000 joules. Your work out will always be less than your work in. That might help you in remembering where your numbers are going to go. And divide that 200 divided by 250 is 0.8. Okay. And we simply multiplied that and got 80%. So you have a 80% efficient lawnmower. And that's actually a pretty good efficiency for a hand mower. This time we're going to use a pulley system. In this case, we're going to look at things a little differently because we know our pulley system is 85% efficient. If 500 joules of work is done on the pulley, and that should say on the pulley, that means you are going to pull on the rope with 500 joules of work. How much work will the pulley put out for us? How much will it be able to do? Okay, so again, efficiency is work out divided by work in times 100. What we are doing is finding the work out, so we're simply going to rearrange our equation to find work outs, okay, which means we have to move the work in to the other side. So we're going to take our efficiency, we're going to take it and convert it into a decimal, and then we are simply going to calculate that. Now you can change it into a decimal by dividing by 100 like you see there with the equation. Okay. So we have 85% times 500 joules. And again, by dividing by the 100%, your percentages are going to cancel out. You're going to be left with joules. So 0.85 times 500 will give you 425 joules of work out. Okay. It will give that much work, or that much work is what you will get out of the pulley system. Another way to look at this problem is again in this case, is finding the efficiency of the pulley. This time we're going to look at force and distance. The man is pulling the rope 20 feet with an average of 25 newtons. The pulley in turns lift a 75 Newton crate 5 feet off the ground. So this is where you have to be able to calculate work in and work out. Okay, so when we set this particular problem, we're going to have to do forces and distance out to get the work out, and we're going to have to do forces and distance in to do the work in. If we read through our problem here, 75 newtons is lifted 5 feet. That's how much work comes out of the pulley. The man applied 25 newtons over 20 feet. 75 times 5 divided by 25 times 20. So if I take the 75 times 5, that's going to give me 375. And I'm going to take that 375 and I'm going to divide by 500. That's 0.75. 0.75 times 100 is 75% efficiency. Okay, so that is going to be the final of the practice problems. I didn't work all the possible types of things. I did show you one in which you could calculate the work out. You might also, on your worksheet, be calculating the work in. Okay, so again, just rearrange your equation so that you can start that, but you're always going to start with efficiency being work out divided by work in times 100. Okay, so now just go into your Canvas module, open up the efficiency worksheet, work the 10 problems, making sure again to show all your work. And once you have that, there is a drop box and assignments for you to turn that in. Have a good day.